So I was scrolling through my Facebook feed the other day, and I'm a member of a Python group, a member of multiple Python groups, where I like to read people's questions and provide answers and try to help them with the language. And I saw a seemingly kind of simple question, and it made me actually think a lot. He was like, is this good code for detecting a palindrome? So you can see it takes an input here, it assigns an empty string, it does some manual reversing of the string on lines 6 and 7, and then it checks if the reverse string equals the input string, and it prints, is it a palindrome? And then it prints, it's not a palindrome if not, which this kind of works. So we'll just go ahead and run it. If we put in a race car, just ignore that because that's the wrong thing. If we put in a race car down here into the bottom of our terminal, no spaces, no capital letters, it says it is a palindrome. And then if we put in something else, like palindrome, it says it's not a palindrome. So you can see it works for the basic case, but if we actually did put in a race car, it obviously says it's not a palindrome because we're not scrubbing spaces and we're not checking the casing. Also, this is a lot of lines for something really simple, and you can also use a Python built-in function to reverse a string. So I recommended that he use just this 2 lines of code, and also to actually say what the input is. Please enter text to test if it's a palindrome, because as you can see when we were running this code down here before, it just goes into a blank screen and you don't really know what you're doing. Don't know. Oh, palindrome. Okay, let me rerun this. But whereas if we run this guy, please enter text to test if it's a palindrome. And I keep doing this. So it's a palindrome. What I was able to do here to get this to be like significantly smaller code is I made use of the Python 3 fast formatting strings. I used a ternary operator, and then I used in the built-in list splitting to go ahead and reverse the string. I also found out that this list splitting is significantly faster than manually reversing the string using iteration. I'll show those benchmarks in a little bit. So again, much simpler code, but it still only checks for the base cases. I'll show you how I expanded on that to make it get rid of the spaces, get rid of any special characters, and then to go ahead and tell you if it's a palindrome from that. So a much more complete solution. All right, now if we were to take that same capability to test if it's a palindrome and put it into something more production worthy, this is what I imagine that code would look like. So here we have a modular function that we can import in our other scripts. We'll see that in the benchmarking script that I created for this. And we have some commenting here to explain what's going on in the script. So make everything lowercase, remove all the special characters, manually reverse the string if we are not using our optional argument here for fast formatting, or to use the Python built-in to go ahead and use the fast reverse function. I put that as kind of an option to go between those two choices so that you can see the impact in the benchmarking on how much faster this actually is. I think Python is doing some magical memory manipulation to reverse the string in memory as opposed to actually creating new memory and going through instructions to make that happen. So I was kind of really impressed when I saw that. So again, we'll see that in the benchmarks. And then we just return the result. So this will return a Boolean. And then we have the if name equals main down here. So if you are importing the script, it's not actually going to run this logic. But if you are running the script as a standalone script, it will run everything under line 20. So it'll run through these. And it's the same thing. It will get the input. It will get the result of the function above, store it in is palindrome, and then we'll use the same kind of fast formatted string and ternary operator to display the output instead of having the 4 lines for a very simple logic comparison. Also, if you want to learn more about the fast formatted strings, the palindromes, and kind of the logic behind the different optimizations, check out the blog article I wrote on this. It's pretty complete, and it has good code examples that you can copy and work through yourself. So let's just go ahead and run this so you can see that this works. Format input.py, and we'll go with the race car with the capital R and the space, and we'll put in some symbols too at the end just to kind of see. So you can see that is a palindrome. And just so you know it's not hard-coded, we'll go ahead and type palindrome in here too. So you can see that that is not a palindrome. Also, another thing with this format and test palindrome function is lines 5, this will do an operation on every single character in the string. Line 8 will look at every single character in the string as well to do the substitution of the special characters. So here, if it is not a alphanumeric character, substitute it with a blank empty string. So this dumps everything using regexes. Again, this resub operates on every character of the string. Same for this right here, this S2 reversed. It iterates through every character in the string. So here you're looping through it multiple times. There is actually a more optimal way to do this using a left and right pointer. So let's go ahead and look at that. Here's our optimized version of the palindrome code. Here we declare a left and a right pointer. What we're going to do is we're actually going to divide and conquer the parsing of the string from the left and the right side. That's what we're doing in this while loop here on line 11. If we see an alphanumeric character on any one of the 2 pointers, we just keep moving the pointer until we're not seeing an alphanumeric character anymore. So we're not like removing it or anything, we're just skipping it as we go from left to right. Then we have our break early condition, where if the left pointer character is not the same as the right pointer character, we just go ahead and break the parsing and we return false. That allows us to fail faster, whereas in the format palindrome, we have to look at every single character in the string 3 different times, no matter what. This one, we just do the parsing and then we fail automatically if it's not correct. So this will actually save us a lot of time in the case where the input is not a palindrome, which is more often than the case when it is a palindrome. That might not seem like a lot in our toy example, but when you think about a larger production system, if we can fail faster, we end up saving a lot of cycles and processing time. So that's an important thing to do even with our toy examples. Then we get down here to the bottom and we return our is palindrome flag. Then we have the same case where if we import this as a function, we're able to import it as a function, or we can run it as a standalone script where we just enter the text to test if it's palindrome, and then we say if it is or not. So let's go ahead and run this so you can see that this works. So go with our toy example, race car, it is a palindrome, not a race car, it's not a palindrome. And you can't actually see that it failed like very quickly since it's just a single line. So I went ahead and wrote up a benchmarking script to talk through this. So here in the benchmark palindrome, we have a input string, which is just A's, different uppercases and special characters inside of it. And then we go ahead and make it really long. The reason we want a really long input is because of the way our optimization is working from the outside in. And the way the other script is working on a string multiple times to actually see the difference in what that logic is doing, we need a long input. So then we use the time.time module to go ahead and time the different functions. We loop through the different tests to get the outputs, and then eventually we just output the 2 times. Again, this is the case where it is a palindrome, and we are using the reversing it ourselves by appending all the characters together. So let's run this. So you can see the slow palindrome latency is 1 second, 1.09 seconds. And you can see the optimized one is 0.14 seconds. The slow one is where we do all the operations multiple times. The optimized one is where we are working from the left and the right pointers and working our way inward. So we don't actually reverse the string anywhere. We're just looking at the characters in line. And then if we actually use the splitting operation of Python to reverse it in memory, we do end up actually getting a significant time savings. So let's rerun this using the splitting notation where s::(-1, and we use that instead of actually reversing it ourselves. So we will go ahead and run this one, and you can see that that one's actually faster by a lot, 0.04. It's not doing any iteration at all. We're still doing the same parsing required to remove alphanumeric characters and the cases, but in this case, this is just doing it on a reverse string in memory, where this one we're still looking at the left and the right pointers and iterating and incrementing our pointers and all that fun stuff. The other thing I called out is that the optimized palindrome algorithm really works to like fail fast. If we're given test input that's not a palindrome, we should see that this is even significantly faster than the one that uses the reversing in memory. Now we'll use input that's not a palindrome, and I'll show you how that affects the latency of the two different algorithms. Here, this is our second test palindrome. It has the B character in it, which there's no B on the right side to match that. We'll save this, we'll run it, and you can see the slow palindrome latency is 0.05, which is about the same thing as we saw in the first run of it, but our optimized palindrome latency is actually 0.0. Just so you can see that this is actually running a time and it's not a mistake, we'll go ahead and run this on 5 more sets of the algorithm. Okay, and 5 more sets isn't enough. Let's do an extra, we'll double our input cases as well, or we'll double the length of our input string. That's not actually going to do that much because, like I pointed out before, this fails fast, so making a longer string isn't really going to do anything. Let's actually just increase our test input by another factor of 10 to be 100. All right, so you can see it's still failing extremely fast compared to the slow palindrome latency. This is actually going to take 10 seconds. All right, here we go. So when we had 1,000 test inputs, we actually got a measurable latency for our optimized palindrome algorithm. So you can see slow palindrome latency 9.8 seconds, which I called out that it should be about 10. And then our optimized palindrome latency 0.0009. So it failed extremely fast for all 1,000 of these test cases. Doesn't mean that much in our toy example, but when you are running on production systems, you want to be aware of these kind of optimizations. Thank you for listening. This is Stefan from Be a Python Dev. Please visit the blog if you want to learn more about Python development and software engineering best practices. Have a great day.